1-3, solving equations. We're going to be writing an algebraic expression to represent each verbal expression in the first two problems. You have to get used to being able to go from English sentences to math equations and expressions. So on problem 21, it says 4 less than the square of a number. 4 less than means we're going to be subtracting 4. So I start off with putting a minus 4. 4 less than the square of a number means a number times itself. So we're going to have n squared in front of that. So it's going to be n squared minus 4. 4 less than means I have to be subtracting 4 from something. Problem 23 says 5 times the sum of 9 and a number. 5 times means I'm going to be multiplying. The sum of 9 and a number means I'm going to need parentheses. And I'm going to take 9 plus some number. Now you can use whatever variable you want. You don't have to stick with n's, x's. So now 5 times the sum of 9 and a number is 5, and then the parentheses, 9 plus n. On question 32 and 33, they're asking us to go the other way. Write a verbal expression to represent each equation. They have 3a cubed is equal to 2a plus 4. That's what it's looked like, so you can write it pretty much the same way. 3 times the number cubed is always means equal, so that's helpful, is 4 more than the number. You have to make sure you say then the number. You can't just say a number because you have to say that it's the same number. So that's why we say 4 more than the number. Problem 33, we would take a number divided by 4 is again means that equal twice the sum of the number and 1. So twice means I multiply by 2. The sum of the number and 1 means I have that parentheses going. Now we start solving a lot of equations, and you should always remember to check your solutions. If it says solve each equation and check your solution, usually that means they're going to be looking for your check to see if it does check. So problem 44 has us x plus 9x minus 6x plus 4x equals 20. Left side you have all x's, so when we collect them, this is like having a 1x there. So 1x plus 9x is 10x. Subtract a 6x, I get 4x. Add the 4x, I get 8x. So now I have 8x is equal to 20. Going in there, I'm going to take the 8x and then divide it by 8, which means on the other side I have to take the 20 divided by 8. So when I simplify it up, I get x equals 2.5. The check now means I'm going to take 2.5 plus 9 times 2.5 minus 6 times 2.5 plus 4 times 2.5. Does that equal 20? Well, when I start checking it, I get a 2.5 plus 22.5 plus 15 plus 10, and yeah, it does check out to be 20. Problem number 47, we see some multiplication going on. Our goal in solving equations is always to isolate the variable, so we're going to take and divide both sides by that negative 9. So when I take both sides and divide by negative 9, I get a negative 3 is equal to y plus 5. Still need to isolate the variable, so I'm going to move the 5 over by subtracting it. So I get a negative 8 is equal to y. And then again, go and do a check for it. Does 27 equal negative 9 times the quantity negative 8 plus 5? Well, when I take a negative 8 plus 5, I get a negative 3. Multiply that by -9, I get 27. And yeah, 27 does equal 27. It checks. The last problem for this group that I picked has a variable on each side. You have to always get all your variables to one side, all your numerical values to the other side. My rule I always say is move the smallest of the variables. So we're going to move that 3D over by subtracting the 3D. When I do that, I'm left with 7 equals 3D plus 5. Now I have to isolate the 3D, so I'm going to move that 5 over by subtracting. So now I have 2 is equal to 3D. Dividing both sides by 3 to isolate the variable and get it to be a 1D will give me 2/3 is equal to D. Again, do a check of it. You're going to take your 3 multiplied by 2/3 out of 7. Is that the same as 6 times 2/3 plus the 5? Well, when I take 2/3 times 3, I get a 2 plus 7, which is a 9. On the right side, when I take 6 times 2/3, 6 times 2/3 is 12/3, which is 4, plus 5, which is 9. It checks. And the very last problem is another story problem. It says on problem 66, a school conference room can seat a maximum of 83 people. The principal and 2 counselors need to meet with the school students' athletes to discuss eligibility requirements. If each student must bring a parent with them, what is the maximum number of students that can attend each meeting? So they're asking us how many students can attend. So that's our variable. N equals the number of students attending. Make sure you identify the variable. Now we need to come up with an equation. Each student has to bring a parent. So that means it's the student and the parents. That's a 2N. We have the principal and 2 counselors, so that's 3 more people in the room for a total of 83 people. We can't go over that 83. So for the N, it's how many students. We double it because it's the student and a parent, plus the 3 being from the principal and the 2 counselors. So I've identified the variable, I've written my equation, and now I start solving it by moving the 3 over, so I isolate the variable. So now I have 2N is equal to 80. Dividing both sides by 2, so I isolate the variable and get it to be a 1N. I get N is equal to 40. Now, because they asked how many students, you label it as 40 students. Don't forget to label any of your answers. Go back and check it. Make sure it works.